well, you know by now. And it's on present value. Present value is like the principal part. So it's solving for the principal. So it's answering the question, how much money would you have to invest to have this much at the end? We're going to see a few examples of this. So if we say A is the future value, then P is the present value. So in terms of letters, it just means I'm going to replace a couple letters here. A and future value mean the same thing. P and present value mean the same thing. So when I write this equation, it's going to use FV and PV, but it's just the A and P. That's what they are. So how do we calculate the present value? Well, basically, we just rearrange the equation we used yesterday for compound interest. This is the equation we used yesterday. If we want to solve for the principal, we've got to divide away this bracket with the exponent. If we do that, we do it on both sides. And we end up with this. And that is an equation for present value. I'm just going to replace the letters here. P, I'm going to say PV, present value. And A, I'm going to say FV for future value. And then we have 1 plus I to the exponent n on the bottom. And this is our equation. Now there's an or you can use exponent rules and you can write this in the more conventionally used version of the equation. Remember the negative exponent rule was like flip the fraction and change the sign? Well, you can use that in reverse to simplify the way this looks. And it just means that you can take this power in the denominator and flip it to the numerator by making the exponent negative. And this is the version of the equation that you see more commonly with the negative exponent. In fact, it looks exactly like the original, A equals P times 1 plus I to the exponent n, except A and P have switched spots and the exponent's negative. So you can use whichever version of the equation you want. We'll commonly use the bottom one, but if you prefer, you can use the top one. Okay, so there are a bunch of examples in this lesson. We're going to do 3 of them. I'm going to skip 2 of them, and I'm going to ask that you try those 2. Now, when to try those 2 is up to you. If you would like to watch an example, pause the video, try an example, that would be a fairly good strategy. If you would prefer just to watch the 3 and then try the 2 after, that's fine too. They're going to be of similar type to the one that I do. So I'll do one, then the one I skip will be just like the one that I just did. So let's give a couple of these a shot. Note, these calculations do not include time value of money. So something I touched on briefly at the beginning of the lesson yesterday, and it's that $10 today is worth more than the same $10 20 years from now. And that's because you can invest the $10 now and earn interest. And the $10 from back in time is generally worth more. And that's why you hear all the time, like, if your parents are describing like how much they paid for their house or how much their down payment was or how much they paid for their first car, it's always going to be far less than what you paid for your first house potentially or your first car. And it's just because things cost more now, and it's not because they're more expensive, it's just money is worth less. So all these calculations don't really take that into account. Inflation is the rise in the general level of price of goods and services in the economy. And there's something called opportunity cost that's also not really considered, is what you miss out on when you choose to do one thing instead of another. So for example, if you spend your $10 on dinner, you miss the benefit of using that $10 on anything else, such as like depositing into a savings account and earning interest on the $10. So these things aren't really considered. These are just straightforward mathematical calculations as to what would happen in terms of just interest. All right. Number 1 is the one we're going to do. Number 2 is the one I'm going to try to get you to do. Chloe puts $2,500 down on a new car and finances the rest at an interest rate of 7.8% compounded monthly. 5 years later, she paid $28,469.78% for the principal and the interest of her loan. How much did the car originally cost? Well, the original cost of the car is going to come in 2 parts. It's going to come from the down payment and how much she borrowed. So this $2,500 down is going to be used at the end of the question because that came off the price of the car at the beginning, and then she financed the rest. This financed the rest. Here, I'll highlight it in yellow. The rest, that's the principal, or that's the present value. That's how much was left on the car when she borrowed money. Then we have an interest rate, and we know it's compounded monthly, so that magic number we're going to use to find I and N is 12. This is our interest rate. 5 years later, there's your time. She paid $28,469.78 for the principal and the interest. That's the future value. How much did the car originally cost? The original cost, that's the PV. So in order to use the equation, we need to know I, N, and the future value. Well, we know a few of those things, so I'm just going to write future value, I, and N. The future value was $28,469.78. I is the interest rate as a decimal divided by the number of times we compound. So we've got 0.078 divided by 12. And if we do that math, we get 0.065. N is the number of years times the number of times we compound. Because we're calculating interest 12 times a year, and we're doing it for 5 years, that means we're calculating interest 60 times. So now that we know F, I, and N, we can use the present value equation that I wrote at the top. PV equals FV 1 plus I to the negative N to figure out the present value. How much she borrowed to buy the car. Now the value of the car was the borrowed amount and the down payment, so we'll add that on at the end. Future value, $28,469.78. 1 plus 0.0065 to the exponent negative 60. It's important we get the negative exponent on there or we're going to get the answer wrong. And when we do negative on my calculator, I got to use the little minus key, this plus minus key down here. You'll know when you use your calculator. If you get error, it's because you use the subtract key. You got to use the plus minus key or the negative key. So here we go, 28,469.78 bracket 1 plus 0.0065 close bracket exponent and then negative 60. And we get nice number, 19,300 even. There's the present value. So that's how much she financed. Plus the down payment. Down payment comes off the price of the car when you buy it. So how much did the car cost? Car cost. Well, it costs 19,300 plus 2,500. So the value of the car was $21,800. Now, how much did she pay for the car? Well, she paid $2,500 and $3,800, or sorry, $3,800, $28,469.78. So she paid that and that, which is over $30,000. It's almost $31,000. That's like $10,000 more than the car was worth. That's why when you borrow money to finance a car, you end up paying a lot back. Your goal when borrowing money is to try to get something with a really, really small interest rate so that you don't have to pay extra money, because that car, being only worth $21,800, paid in almost $31,000. It's a lot of money. Okay, so a similar example here, number 2. You don't have to deal with the extra calculation at the end. There's no down payment in this one. It's just a straight PV calculation. So try that one on your own. We're going to jump ahead and discuss something called timelines and do 2 more questions. So sometimes doing a question like the Chloe buying a car, it'd be a good idea to draw something called a timeline. It helps you organize your thoughts before you do a question to see what you need and what you have. So here's a word problem, and I've converted it into a timeline. And if you want to use these as part of your solution, feel free. It's not a requirement, though. This says Allison's parents invest $5,000 at 4.8% compounded quarterly. How much will the investment be worth on her 21st birthday? Similar to the one we did yesterday, your timeline starts now and it goes until the end of the investment, in this case 21 years. We break the years up into how many times we compound, in this case quarterly, so you can see there's a little tick for every quarter. If you count all the ticks, that would be your N. I would be calculated by taking your interest rate and dividing by 4, so we show that here. And since we know the money at the beginning, we write the money at the beginning, P, 5,000. If we were given A and wanted to work backwards for P, we would write the amount here, and we would work backwards to get P using the equation we just used. So originally I was going to have you draw timelines for these ones, but I don't think it's a requirement. So we're not going to do that. We're just going to solve them using the equations. So let's try one. Hunter has an investment which is compounded semi-annually at 5.3% per year for 8 years. If its future value is $15,200, how much interest will it earn? Okay, so to find out how much interest it will earn, we need to find the principal, because interest is the difference between the future amount and the principal. So first step is going to be to find PV. So in order to find PV, we need to know the future value, I and N. So I'm going to go through and we'll highlight one at a time. The future value just explicitly says future value is $15,200. For I, we have semi-annual 5.3%. Semi-annual means 2 times per year, so 2 is going to be our magic number, and the number of years is 8. So let's do N first because it's a pretty quick calculation. 8 years times 2 equals 16. For interest, 0.053 is the interest rate as a decimal, divided by 2. Remember, I divides by 2, N is times by 2. That is decimal 0.0265. Now that we know F, V, I, and N, we can use our equation. The equation is future value, so 15,200, times 1 plus I is 0.0265, to the exponent negative N, negative 16. If we type that in our calculator, I'm going to save the calculating time, we get 10,231. So that was how much the investment was for. That's how much the investment is at the end. The difference is the interest. So if we want to find that, we use that second equation, amount minus principal. That will always give you the interest. Amount is the future value, 15,200. Principal is the present value, $10,002.31. So the interest earned is $5,197.69. All right. What if we're asked to solve for something that's not the present value or the future value? We could be asked to solve for interest rate, and we would have to use roots to solve for that. And there was an example in yesterday's lesson. It was one of the extra questions you were to try, so hopefully you tried that. But if not, give it a shot because it is important to be able to do that. I want to do an example here where we solve for the exponent, where we solve for n, because I want to show you two strategies, one of which I would expect you to be able to do, and one of which would be kind of an extension that maybe we would learn how to do next year. I'm going to show you how to do it now, just so you can solve it. But let's give it a shot. If you want to try another one like A, try B. B's got that extra down payment part, so it's more like the one we did on the last page in terms of that. But give it a shot and see if you can come up with the right answer. We're going to do C. Last question. Kieran borrowed $6,800 at 3.4% compounded semi-annually. He knows he will pay $7,781.74 for the principal and the interest at the end of the loan, but he can't remember how long he made the investment for. How many years is Kieran's loan? So this time, I'm going to write all the variables on the side here. And since we know the future value and the present value, you can use either version of the equation. It actually doesn't matter in this case. So I'll just use the simple compound interest equation, but he borrowed $6,500. That's a present value. He knows he will pay back in the future. That's a future value. We have some information about the interest rate. We know it's semi-annually, but we don't know the time. How many years? We don't know t. So if I write all my letters down the side, future value, present value, interest rate, and n, the one we're missing information about is n, because it's some number of years times 2. It's something times 2. So we're actually going to end up solving for n. We want to find n so that we can figure out t. I, we can figure out, because it's this decimal divided by 2. 0.034 divided by 2 is 0.017. Present value is 6,800. Future value is 7,781.74. And again, we can use either equation. I'm just going to use this one, the standard compound interest equation. We're using FV and PV, but remember FV is just A, PV is just P. You can replace them and write them like that if you want. I'm just going to fill them in. 7781.74, 6,800, 1 plus 0.017 to the exponent n. So now at this point, your first strategy is honestly just guess and check. It's guess n's, guess nice whole numbers like 1, 2, 3, 4, 5, and keep going until you can figure out what n is. And we'd just be looking for the nearest n, so the nearest whole number. So don't worry about decimals, you just go until you get this amount or more. Yeah, guess and check is one strategy. So we could say, I'm just going to say guess and check. Now, guess and check is not necessarily the most mathematical approach. So there is math that you can do to solve for an exponent. We just haven't learned it yet. I'm going to give it to you now, and if you want to use it, you can. And if you don't, you will just use guess and check. So how do you do it? Well, we have to take one math step. We have to divide away the 6,800. So we get a number equals a power, and then we can use it. So divide away the 6,800, we get 778174 over 6800. And that'll equal, I'm going to add those numbers together, 1.017 to the exponent n. So now what you can do is you can use the log button. And how you use the log button is, because of the log laws that you're going to learn in advanced functions, you can take the log of the left divided by the log of the right, and that will give you the exponent. So what's that look like? That looks like this. Log of the left, log 7781.74 divided by 6800. We can do that divided by log of 1.017. If you type that in your calculator, you will get the answer, the exact answer for n, without guessing and checking. So, what is that? Log is the LOG button. You have to use the one that says LOG, not the one that says like log with a box or log where you can change the base. Just the straight up log button. You could also do it with the ln button. It would work too. Log. Type in the division. 7781.74 divided by 6800. That's the first log. We're going to divide that by the other log, 1.017 equals 8, basically. So n is 8. And if we went and guessed and checked, we would see that 8 works. So I'm going to show you that 8 works. 6800, 1.017 to the exponent 8 should give us that number. And it does, pretty much exactly, actually. So 8 is the answer for n. But remember, we want the number of years. The number of years was multiplied by 2. So if we want t, we got to divide 8 by 2. And we get 4 years is the final answer. And I know I should be writing therefore statements, but I do not have the room, so I'm not going to. We would say, therefore, Kieran invested for 8 years. Okay, so why does the logs work? That's a conversation for future math classes. Can you use the logs to get the answer? 100%. Do you need to understand why right now? Why it works? No, you do not. But if solving for the exponent, 2 options. Guess and check, log button. I would suggest log button, but if you can't remember how to do it, guess and check. All right, that's it for present value. Thanks for watching, and I'll see you next time.